let's learn bagging versus boosting versus stacking. So these all belong in a group of methods called ensemble methods. An idea of ensemble methods is you want to combine multiple models, not necessarily combine, but use multiple models to improve predictions. For example, let's say lesson overfitting. So let's start with bagging. First step of bagging is, let's put a star. Let's add some colors. That'd be more fun. So, bagging. First, we want to bootstrap sample observations with replacement. 2, we're only going to use subset of features for each model. And then step 3, we're going to build many models using step 1 and step 2. And then our prediction will be, say, majority vote of the models, or to be, if it's a majority vote if it's a categorical variable, and then if it's a continuous variable, say average of the models. And we have two sources of noise here. We have a source of noise coming from the bootstrap sampling, and another source of noise coming from the using subset of features for each model. And then one outcome to this is you'll probably lessen overfitting because you're adding those sources of noise. Next topic, let's do boosting. So idea of boosting is each new model overweighs mispredictions from the previous model. So you can have your first model, you're going to have some mispredictions. In your second model, you're going to actually weigh those mispredictions anymore. And then moving on to your third model, you're going to look at what happened with model 2. Any mispredictions there, weigh even more, and you continue that process until you get a final model. Last topic is stacking. So with stacking, first of all, we're actually using all the data, unlike bagging, where we had a bootstrap sample of data. And another unique thing about stacking is you can actually use a combination of models. Combination of models allowed, you don't have to. So you can use, say, a decision tree, logistic regressions, k-nearest neighbors, what have you. And then finally, the key point of stacking is the predictions from each model. Predictions from each model is appended to the data as a new feature. As a new feature. For example, let's say you had 3 models. You're now going to have 3 new features to use.